Hello dear students, in today's class we are going to learn an interesting lesson of class 9th physics, that is gravitation. You have studied in the lesson force and laws of motion, that is Newton's laws of motion. If there is motion of any object, there must be a force involved. If there is no force, then there will be no motion. Yet we can find some of the objects, when they are thrown upward, they come back to the earth. They fall back to the earth. If there is a ripened fruit on the tree, it falls to the earth. Then there also should be a force acting on that apple or any fruit which is coming towards the earth. In the same way, it is said that when Sir Isaac Newton, when he was sitting under a tree, an apple fell on him. Then he started pondering over this matter. If the apple is falling on him, then there must be a force involved in moving that apple from the tree to him. Not only this, he also started thinking that if the moon is moving around the earth, that moon should also be falling towards the earth, because apple is falling, then moon should also be falling. He started thinking like this. But moon, even if it is falling, it cannot be seen at all. Then how to understand this, whether moon is falling exactly towards the earth or not? Let us take an activity. That is, if you take any stone and tie to a thread and just start revolving like this, when you rotate that thread holding at the center, you can see the stone which is moving in the circular path. It is changing its direction at every point of the circular path. What is happening is, if the stone, as you are rotating that one, if you leave it, it goes in a straight line which is tangent to the circle. In this direction it moves, right? But as long as you are holding the thread tightly, it is not going anywhere. Means instead of following this path, it has to change its direction, right? It has to change the direction again. After coming here, again this becomes tangent. Again from here it has to change the direction. Means at every point it is changing its direction, that moving object, right? When it is moving in circular path, it is changing its direction. If there is change in direction, again there is change in velocity. Change in velocity is nothing but it is change, or that is acceleration. Change in velocity is nothing but acceleration. It is here, this acceleration, it is caused only if there is action of force. If there is no force, then there is no acceleration, as you already studied. This acceleration it is getting just because it is at every point, this stone, it is falling towards the center. In the same way, if you consider, if this is the earth, if this is the moon, at every point the moon is falling towards the earth just by changing the direction. Again it has to be accelerated. Means some kind of force must be acting on that moon or that object which is held by the center of that main object. Okay, then since it is changing at every point its direction, it is holding the object in circular path, and this force which is holding this object, pulling it towards the center, is called what? Centripetal force. The force which is pulling that object which is moving in circular path, which is being pulled by the center, this force, it is called the centripetal force. We call this as centripetal force. Because of centripetal force, the moon is moving around the earth and planets are moving around the sun, right? And even if you are holding any stone tied to a thread, and if you are rotating, that is also keeping in circular path moving there, because that at every point it is changing the direction and it is falling towards the center. If it is falling towards the center, this force which is responsible for making that object to fall towards the center, that is what it is called centripetal force. Now, coming to the same argument what he had already told in the beginning, that is he had told there, that is the same force is responsible for falling of the apple or motion of the moon around the earth. Same type of force is acting on them, he said. And he also said this is gravitational force, he said. And at the same time he also argued that if the apple is falling towards the earth, earth should also be attracted towards the apple, because according to his third law of motion, that is for every action there is an equal and opposite reaction, right? For that purpose, if the apple is attracted towards the earth, earth should also be attracted towards the apple. But according to second law of motion given by him, it says, what is that? For a given force, for a given force, mass is inversely proportional to acceleration. Means mass of the object, as it increases, acceleration decreases. Coming to apple, mass of the apple is negligible as compared to the mass of the earth. Mass of the earth is very much huge. As compared to that, apple's mass cannot be considered at all. So because of that, there is no acceleration for the earth towards the apple. Only apple will be attracted towards this earth, because of there is very much high difference in their masses. Okay, so because of that, earth remains in the same place, but apple is being attracted. He called this type of force, which is keeping all the planets moving around the sun, or all the satellites moving around the planets, this force he called gravitational force. And he said this is not only the force between apple and the earth, and this is not only the force between the planets and the this one moon. He said that all these in the universe, all the objects, they are attracted by another object. This, in broad thinking, he said that gravitational force, any object you consider in the universe, it is attracted by another object. This type of force, he called it as gravitational force. Means we cannot subject this one to only few things which are on the earth. No, it may be the force between moon and the earth, or it may be the force between planets and the sun, or it may be the force between satellites and the planets. Anything it may be. These types of forces which are acting on each other, they're like that between two objects, this is called gravitational force. And he gave this as a universal law of gravitation. One law he derived. What is that? If you consider two objects of mass m and m, and the distance between the two objects is d, if they are attracted towards each other, he gave a rule there. That is one law he gave. What is that? Every object in the universe attracts every other object with a force, which is proportional to the product of their masses. Product of their masses means product of the mass of the two objects, and inversely proportional to the square of the distance between them. Let us call this as equation 1 and equation 2. From equation 1 and 2, we can say that the force which is acting on the two objects, means that attractive force, gravitational force, it is nothing but it is proportional to the product of the masses of the objects and inversely proportional square of the distance between them he gave. And later this can be written as F is equal to m into m divided by g square, d square. And here we have to multiply one thing, that is g is nothing but constant of proportionality, and this is also called universal gravitational constant. So he gave this equation, F is equal to g into m divided by d square. This is universal law of gravitation. He said this. What it says, every object in the universe attracts every other object with a force. Let us write here that one. Universal law of gravitation. Gravitation. He says, according to this, every object in the universe attracts every other object with a force which is proportional to, means directly proportional to the product of their masses and inversely proportional to the square of distance between them. And this force is, he also said, this force is along the line joining the centers of the two objects. This is universal law of gravitation. Here these are coming during the explanation, but the law states like this, right? So how to state that? Every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. And this force is along the line joining the centers of the two objects. It is along the line joining the centers of the two objects. This is the universal law of gravitation. Till here we will stop, and in the next class we will go ahead with remaining things of this lesson. Okay, thank you.